Hey everyone, welcome back to my YouTube channel. Again, I am here with one very good PYQ, okay, previous year questions from GATE 2006 paper, right? And this question was asked in GATE 2012 as well, okay, GATE 2012. Both questions were similar, right? So in that question, in 2006 question, they have given some extra information like, that was common data question. So just nowadays, common data questions are not asked, right? So I'm just taking up this question. You can match this question with 2012 questions. Okay, one of the toughest paper which everyone felt, during the exam in that year, right? So, but the question paper was not that tough, but yeah, our preparation was not that good, right? So let's solve this question, and this question I am going to solve within 3 to 4 seconds, because see, I have already explained you the concept in the previous for gate 2012 paper, right? So you can see, you can go back and check the solution for that. Let's see this question, right? So this question was asked in gate 2006 in ECE paper. And this question was from the common data, right? Common data, common data question. Okay. So what they are asking here is, you can see again the same question which was asked in GATE, 2012 paper, right? And that year 67 out of 100 was the topper marks. So let's see, they have connected, input to the base, and you're taking up output at the collector, not. What they are asking here is the small signal gain of the amplifier, that is VC upon VS. VC upon VS. This time they are not asking only the amplitude. They are asking what? They are asking the magnitude as well as that phase as well. That negative sign will be there. Okay, because this is common emitter and they have given the feedback as well. Right? They have given the feedback. They have given shunt feedback. Okay, shunt feedback. Whenever feedback is given like this, okay, so as I told you that you don't have to worry about the basic amplifier. You have to desensitize the basic amplifier from your calculation. Why you're doing so? Because there is a wonderful advantage. One of the biggest advantage of negative feedback, okay, is that you can better go for desensitization of odd path gain, so that your analysis, everything is going to be very easy. It makes your life very simple. So here you can see, you have to travel from here to here to here to here, right? See, these capacitance and all you can sort, right? Okay, because after all you are trying to find the small signal gain, right? So these capacitances will be short circuited, they are the coupling capacitance, so don't worry about all those things. See, so your answer is going to be what? Your answer will be this upon this. You can consider this as inverting op amp. Okay, consider this as inverting op amp. Okay, the way you calculate gain for inverting op amp or operational amplifier, you know that whenever you try to calculate gain for op amp, what you do over there is, overall gain depends upon the resistances connected around the op amp, right? Why it is happening? Because you are considering that the op amp is ideal and the loop gain is high. Okay, the gain of the op amp is quite high, right? So the overall gain is going to be what? Overall gain is going to be, the open loop gain over there is very high, so it is going to be minus R2 by R1, or you can say minus 53k upon 5.3, right? What you can do here, the k and k gone, and this will be minus, okay, this, what is going to be this again minus. So I think for gate 2012 the answer was 10, because they were asking about the magnitude. Now they are asking what? They are asking also about the magnitude as well as the case, I mean the sign as well, right? So you can see it will give you the negative sign, okay, because you are applying input at the base, because this is common emitter amplifier, kind of a basic amplifier is what? The common emitter, right? And sends and feedback is connected. So can use the benefit of or advantage of negative feedback and you can get the answer directly. A is the option, right? Don't go for a small signal model, okay? Don't draw the small signal model and apply KVL KCL, okay, and waste your time. They're not asking you the answer which is very close to, okay, the answer is going to be, so they have forgotten here, they must have given like this, the AV should be very close to -10. This is one correction they must have done, but yeah, this was asked in 2006, way back when I was studying, I can say ninth standard. Okay, when I was in ninth standard, this question was asked, right? So you can understand how easy this question is. So Ravi Teja sir, once please explain how it is shunt feedback. The Miller theorem se ho jayega na? I use don't complicate your life. Okay, don't complicate your life. Okay. Yeah, Ravi Teja, I'm coming back. I mean, how it is sent feedback. Yeah, wait for that. I use don't complicate your life. Because analog circuit is not all about solving network analysis, right? You might have heard about this kind of a myth. If you are good at network, you can do better in analog circuit. But you know, don't lose the flavor of analog. Okay, use some concepts. Use some concepts. So Ravi Teja, you are asking about. You can use like you can draw the small signal, use Miller theorem, whatever you want to do. But yeah, please, if God has given you the advantage of negative feedback, so you know, utilize the advantage of negative feedback and go back and check gate 2012 question solution I have given, right? So there I have explained in detail, okay, what I have done over. We have completely ignored the basic amplifier, right? Because my overall gain was depending upon 1 by beta, and beta is not the beta of the transistor. Remember that beta is what? The feedback factor from the feedback network, and your feedback network is made up of purely resistances. As far as the op amp is concerned, we do. So Ravi Teja, yes, your question is how it is concerned. So yeah, I'm not going to give you the detailed explanation, but yes, you can see here, you have to keep always this in mind. Let me give you some hint here. Okay, so if this kind of feedback, see, this terminal is considered as shunt, this is shunt. Okay, shunt. Okay, you are taking voltage and feeding here, right, in the base terminal. So this is also kind of a shunt only, right? So I can take you through the op amp, because op amp is somewhat easy, right? This you see here, because both are similar here, okay, as far as you consider the gain is the open loop gain is very high. So suppose this is Vi, right, and this is R1 and this is R2. If you're taking voltage and connecting back to the negative terminal of the op amp, right, so after all, this terminal is basically known as the current summing, okay, terminal, and this will be the shunt connection, and it is also kind of a shunt, right? So you have to always keep in mind some kind of a shortcut to remember. So this terminal is shunt, this terminal is shunt, okay? So if, because in the feedback you might have heard about sampling and mixing, right? Sample voltage and mix, okay? So the all those things, right? So here your output is voltage and input is also voltage, okay? Your output is what? The voltage shunt here, okay, I mean voltage, and output input is basically what? If you see this here, the input is basically current, right? Input is current. Remember this, input here is current. You might be thinking that the voltage is given, but yeah, input is current. How? Because the virtual ground concept you can apply, so this will give you the constant current. Shunt. shunt, and if you something is being done, this is going to be series terminal, right? So as far as the feedback is connected, the resistance is connected here. So can we solve any amplifier question without using it? Yes, 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 yes. Any question you can do, any question, okay? And I'm going to show you. Okay? I'm going to show you those things, right? I'm going to show you. So because as far as the gate question is concerned, any question you can do without drawing any small signal model, okay? And yes, but if there is a feedback, if there is a feedback, so that question becomes more easier, okay? Then we can imagine, right? You might have seen many solutions, 20 year of experiences, 30 year of experiences. You guys follow those, very vague solutions, right? But follow this. Because nowadays in the industries, people, find gain just by inspection, by looking at the transistor. Okay, this is going to be the gain, right? See, if you will spend time, drawing small signal analysis, I mean model, then apply KVL, KCL, hit your brain. So how many hours you're going to spend over there, right? So please keep in mind this kind of a convention. Okay, in detail I will explain what is sampling and mixing and all those things. But in my case, what I do, if there is a output is voltage and input is current, right? So this is how I remember. Okay, if input is current and output is voltage, right? So I consider that if output is going to be voltage, it means that the output resistance is going to be low. And if input is current, then I consider this is going to be low only, right? So if low means shunt, if low means shunt. So this is the voltage shunt, or you can say voltage current feedback, okay? Or you can say the shunt feedback. I hope this you will be able to remember. Yeah. So guys, like these sessions, I'm going to bring all the questions on analog circuit and going to solve, I'm going to solve all the questions based on a small signal without using small signal models. So Ravi, Teja, have you understood now how we have identified that is shunt feedback? So yes. Hmm? Sampling shunt, yeah, there are huge theory, right? But keep in mind for the present, this terminal is meant for shunt, this is shunt, right? So shunt feedback. I'm not going to explain you, I'm not going to confuse you for, yeah, great. So share this channel among everyone, okay, because yeah. So what I'm going to do here is I'm going to talk about analog, I'm going to talk about devices, communication, electromagnetic, signal and system, all these subjects, right? PYQs, sometimes I will also take up the sessions based on your suggestion and request, right? So let's catch up in the next session. Thank you.